So we're going to take a look at section 3.4, which is on the rational root theorem. So we'll talk a little about that, and synthetic division. You'll see me abbreviate synthetic division, capital S, capital D, synthetic division. In the book, sometimes they refer to synthetic division as Horner's algorithm, H-O-R-N-E-R''S. I don't know if that's named after the person that figured it out or whatnot, but if you see anything that says use Horner's algorithm to solve, it just means use synthetic division. Okay, so just to clear that up. Okay, so when we have a graph and we're trying to find the zeros, we can have zeros that are rational, which means it can be written as a fraction. We can also have zeros that are irrational, which means they can't be written as a fraction. An example of a number that's irrational is like square root of 7. If you had a graph like this one, and you graph that on the calculator in y1, x squared minus 7, it would cross the x-axis at 2 spots. Let me show you. So let me type in x squared minus 7. Do zoom 6. Now, if I do second calc 0, it'll tell me where it crosses. Problem is, it's going to give it to me as a decimal. Right? And it says it crosses at 2.6457513. That's not a number that can be written as a fraction. In fact, 2.6457513 is this number. 2.6457, there it is right there. It's the square root of 7. There's no way to write a square root as a fraction unless it's the square root of a nice number, like square root of 4 or square root of 9. That's different. Okay, but square root of 7, you can't. So when you can write something as a fraction, we call that a rational answer. When you cannot, that's called an irrational answer. I'm going to show you guys a theorem for how you can find these answers, the answers that can be written as fractions. This theorem that I'm about to show you would not have done anything to help with this problem. Wouldn't have helped, because the answers to this problem cannot be written as a fraction. So first of all, one thing to understand about this theorem is this theorem does not directly give you an answer. This theorem gives you a list of possible answers. From that list, it's up to you to check and see which ones work. Okay, so that's what this theorem does. It gives you a list of options to pick from. And it is possible that when you make the list of options using this theorem, none of them work. So it's not a guarantee that a number in the list we're about to make is even going to work. Right? It's just a list of options which we will investigate further. So when we have a rational root theorem problem, you're going to have don't write it yet, but you're going to have a polynomial, something like that. It's going to be arranged in order from the highest exponent all the way down to the lowest exponent, or maybe ending with something that's just a number, okay, like minus 6. So here's an example of that written in a more general way. So you're going to start something with the highest exponent, and then it's going to go down, down, and it's going to keep going down until you end with something that's just a constant. There won't be an x at the end, like minus 6, plus 6. There's another one, plus 3. So in other words, it just ends with a number. There's no x. Fix that. When we want to find where this graph crosses the x-axis, there's only 2 numbers in that whole thing that are important. It's the number that's at the very beginning, and it's the number at the very end. So if we were doing the problem we're going to do next, it would be the 10 and the negative 6. Those Those are the two numbers that are important. And what we're going to do, that's a little more information about the polynomial. All the numbers that you have in front here will be rational. You will not have any irrational numbers like square roots. And the last number and the first number can't be zeros. That would mess us up. And they won't be. Okay, the last number, like in that one, is going to be a -6. In another one we're going to do, it's I think it was a +3. Okay, it won't ever be a 0 anyway. So what do you do with the two things circled in red to find where the graph crosses the x-axis, to find the roots? Well, first of all, if it's going to cross at a number that's a fraction, it could be written like that. I'm going to represent the top number that's in my fraction as the letter P and the bottom number as the letter Q. Okay, so if it's going to cross at a fraction has a top number and a bottom number. I don't know what those numbers are in particular because we're not doing an actual problem. I'm just going to represent the top number as a P and the bottom number as a Q. We need to figure out how do we get those two numbers. And this is how we do it. P, and there's different options for P. It's not just one answer. P could be any number that is a factor of the constant. Any number that's a factor of the number at the end. So factors, remember, those are things that divide into something evenly without a remainder. So the number in the top of the fraction is a factor of the constant. The number in the bottom of the fraction has to be a factor of the leading coefficient. That's the number that's in the front. So to figure out your rational zeros, the first step is to list all the factors of your constant, then list all the factors of your leading coefficient. And that's what we're going to try first. Once you start listing all these factors out, and then you set them up as a fraction, you're going to get lots of different options. Not everything you write down is a 0. It's a list of possible zeros. And it might be that none of them work. So you have to then check the numbers in your list on the calculator. And the way we do that is we graph it. And the graph is going to help us figure out if the numbers in our list work or they don't work. Okay, but we're going to graph it. Okay, so let's start by just breaking it down and finding factors, and then we'll go from there. Okay, so here's our problem. It says to make a list of all, add in a word here, possible rational zeros. So what we're going to do is just make a list of possibilities. So the first thing to do is identify all the values that could be in the top of the fraction. Those are all the factors of the constant. What is the constant in that problem? Yeah?
-6.
-6. So can somebody tell me all the numbers that divide into, it doesn't matter whether you think of it as 6 or -6, it has the same answers. What are all the numbers that divide into 6 without a remainder? Yeah?
1, 2, 3, 6.
So 1, 2, 3, 6. And they're negatives. -1, -2, -3, -6. So there are 8 possible numbers that we could have in the numerator. positive or negative 1, 2, 3, and 6. Let's look at the denominator. Q is all the factors of the leading coefficient. What's the leading coefficient in this one?
10.
10. What are all the numbers that divide into 10 without a remainder? 10 or negative 10, it doesn't really matter how you think of it. Hurry up.
1, 2, 5,
1, 2, 5, 10, and
0, 1.
yeah,
The negatives.
all those negatives. So positive or negative 1, 2, positive or negative 5, positive or negative 10. So if this graph is going to cross the x-axis at a fraction, the top number has to be one of these, and the bottom number in the fraction has to be one of those. So what I want to do now is list those out. Okay, I've got a lot of different options, so let's start making a list. So possible rational roots. I want to list all the p's over all the q's. So we're going to try to do that in an organized way. Let's start with this one. Let's put that value in the top. And then let's do it over each different value of q that could be in the bottom. So we could have, I'll simplify it as I go. I could have 1 over 1, which is how much?
1.
Just 1. I could have 1 over the 2, which is just 1 over 2. I could have 1 in the top and a 5 in the bottom. Or I could have 1 in the top and I could have 10 in the bottom. Okay, so we've done all those ones. Let's go to the next one. 2 in the top. What would be the first one with a 2 in the top?
3, just 2.
Just 2, because it's 2 over 1. So just 2. What would be the next one? 2 over 1, then we would have
2 over 2, which is
2 over 2, but we already have that one, so that's a repeat. 2 divided by 2 is 1, so we don't need 2 over 2. What would be the next one? 2 over 5. And the next possible one?
2 over 10.
2 over 10, which is 1/5, but we already have that one. Okay, so sometimes they repeat. Okay, now let's do it with the 3. What would be our first one with a 3 in the top? Just 3. 3 over 1. The next one?
3 halves.
3 halves, we don't have that one. The next one?
3 fifths.
The next one is 3/5. And the next one?
3 tenths.
3/10. We didn't have any of those. So those are all the options with a 3 in the top. And now let's finish up with a 6 in the top. Okay. What would be the first one?
6.
6. Next one would be 6 over 6 over 2, but we already have 3, so we skip that one. Next one? 6 over 5. And the last one? 6 over 10,
Already have 3/5.
but that's 3 divided by 5, so we already have that one. So if this graph, and that's an if, it's not a guarantee, if this graph is going to cross the x-axis at a number that can be written as a fraction, it has to be one of those numbers. It has to be. So that's all they wanted you to do for question 1. Make a list of all possible rational roots. And I would say that's a lot. That's probably the most you would ever have. We don't normally have this many possible options, but it's because we just had so many p's and so many q's. All right, any question on that? Now, let me keep that up. Let's graph the problem we just did, and let's show that it crosses the x-axis one time. So let's look at the picture. So it's 10x to the 5th minus 3x squared plus x minus 6. and I'm going to do zoom 6. So show that it crosses one time. Okay. So here's our graph. And can everybody see that it crosses one time? Okay. So what I want to do now is see, out of all the numbers in this list, which one seems, oops, I don't know why this, I thought I wrote 1/10 here, because it was 1/1, 1/2, 1/5, 1/10. Oh, I think maybe my 1, I wrote it on top of the R. I don't know, maybe I didn't write it, but it should be 1/10. Okay, so what I want to do now is look at this list and start to narrow down the ones that don't make sense. Where does it look like that graph crosses the x-axis? We don't know for sure, but it looks like it's close to what?
Positive 1.
Positive 1. So let's eliminate anything in this list that's not close to positive 1. Okay? Is negative 1 close to positive 1?
No.
No. Let's cross out the negative. How about positive or negative 1/2? Is that close?
Yeah.
Yes, positive.
The way it's set up,
Well, I mean, if
it
you
wouldn't look it.
if you look at that, does it look like it's crossing at a half? A half would be right there. No, I mean, I'm not zoomed in a lot, but I can tell it's not a half, because it looks like it's going right over the tick mark, which is at 1. So it's definitely not a half, and it's not negative a half. Could it be positive or negative 1/5?
No.
That's even closer to 0, so no. Positive or negative 1/10?
No.
No, that's even closer. How about positive or negative 2?
No.
No, that one doesn't make sense. 2/5 is 0.4. No, that's even smaller than a half. 3 or negative 3? No, we're even further away. 3/2, that's 1.5. No. 3/5, that's 0.6. No, it's not. I mean, it's closer to 0.6, but I can still tell it's not at negative 0.6 or positive 0.6. 0.3. No. Positive or negative 6?
No.
No. 6/5. That's about, well, first of all, how about negative 6/5?
No.
No, it's definitely not negative 6/5. I mean, maybe you could argue positive 6/5, because that's just a little bit more than 1/6.
That's 1.2.
It's about 1.2, which, it would probably be about right there. So that's still a little bit off, I think. But if you said 6/5 looks like it could be, I wouldn't mark that wrong. It's close to that. But like 6 I would mark wrong. It's not even close to it. So the only two numbers I would say that it's even close to are positive 1 and positive 6/5. And I think it's closer to positive 1. So what I want to do now is let's find the root. Let's actually find it. Second, calc, 0. Pick a point to the left, go to the right, and hit enter. And this is what we get for the root. 0.9505. I'm not sure if you can see it, but it says 0.9505. Remind me again, all these numbers that we had, what were they?
Possibilities.
They were all possibilities for the root. And what kind of possibilities were they?
Rational.
They were the rational possibilities for the root. These are the only possibilities for the rational root. We narrowed it down to two numbers. Positive 1. Is it that number? No, that's not positive 1. 6 divided by 5. Does it come out to that number?
No.
No. So that number, 0.9505, is where it crosses the x-axis. And it's not in this list. What does that mean about that number?
It's irrational.
It has to be irrational. Yep. So, since the root is 0.9505, that is not in the list of rational options, the only other thing it could be is irrational. So since the root is 0.9505, and that is not in the list of rational options, it must not be rational. It's irrational. So this is the most unsatisfying rational root problem you could possibly have, because you do all the options, you list them all out, you use the graphing calculator to help you confirm which ones look reasonable, and it actually ends up being none of them. None of the rational roots here actually helped us to figure anything out. We didn't know that before, and you don't. So sometimes you have to do the rational root theorem, and you don't know what the result is going to be. In this case, it was useless. It didn't help us. Okay? But in a lot of cases, it will help us. Most of the time it will, but this is one where it didn't. Okay, any question on that idea? Okay, so that's the rational root theorem. We're going to come back and we're going to try a couple more. But I want to combine the rational root theorem with a new way to do long division. And these two things are going to they're going to go together. Think of them as they're like two tools. And we're going to use them together. Now, this trick, or this division process, it does not work all of the time. So let me start with that. Long division works all of the time. Synthetic division only works some of the time. It will work as long as your denominator is x minus a number. We saw that yesterday. What did we learn yesterday? That only works if the bottom is x minus a number. Yeah?
The remainder theorem?
Exactly. So the remainder theorem and synthetic division, they're both shortcuts, and they both can only be used in the case when the bottom is x minus a number, or technically x plus a number if you rewrite it. All right, so what I will do is, let me see, do I have the example? Okay. I'm going to show you a step, and then I'm going to do that step in a problem, just like yesterday's example. So let's write, I'm just going to reword the directions here. Divide that by, would have been great if I looked at the number before I erased it. Okay, so they want us to divide that cubic polynomial by that linear one. Now, first of all, is the denominator set up in a way that synthetic division would apply?
Yes.
Yes, it is. It's x minus a number. So what we're going to do is take the number that comes after the minus sign, just like with the remainder theorem, put that number on the outside of a bracket. Just like that. On the inside, we're going to write down all the coefficients of the numerator. F of x is the numerator. That's what's in the top. What are my coefficients of what's in the top? 2,
Negative 5.
-5,
1.
and 3. Just like yesterday, if you are missing any, you have to fill in zeros for the missing ones, and it just leaves space for that column. Okay, so that's your first step. Number after the minus sign goes on the outside. Coefficients of the numerator go on the inside. Okay, now, we're going to bring down the first coefficient. So what I do is I draw a line, just like that. Bring down the first coefficient under that line. That's step 2. Okay, step 3. Multiply the divisor, that's the number on the outside, by the number you just brought down, and you're going to put the answer right there. What's 3/2 times 2? 3. And you're going to put the answer in the second column. So we did 3/2 times 2, put the answer in the second column. Now, what did we always do with our columns yesterday? We subtracted them. Not today. You're going to add them. So you may want to, make a note that that's different. You are adding the columns. What's -5 plus 3? -2. And now we do that again. When we're done, I'll explain to you what these numbers in the bottom represent. So the next one, 3/2 times -2. What's 3/2 times -2? That's -3. Add the column. What's 1 plus -3? -2. So we're going to do the same thing we did again. What's 3/2 times -2? -3. Add the column. 0. These are the numbers that are important for your answer. What do you think the 0 is? That's your remainder. And what do you think those numbers are?
Quotient.
That has to do with the quotient. So the last row contains the coefficients of the quotient, and the number all the way on the right is the remainder. So how do you know where to put those? Well, you kind of work your way forward. That's -2. The next term is the linear term, -2x, and the next term is the squared term. So this is the squared term, the linear term, and the constant. They're the numbers that go in front of the variable. Okay, any question on that? We're going to do another. So since I got a remainder, of 0, what does that mean about x minus 3/2? It is a factor. So because it's a factor, we can factor the problem. So take the original problem, 2x cubed minus 5x squared plus x plus 3. And let's factor it. We know x minus 3/2 is a factor. This is kind of like what we did yesterday. What would be the other factor?
That side divided by x minus 3/2.
You would have to to figure out the question mark, you would have to take this and divide by x minus 3/2. But that's exactly what we just did. So based on what we just did, what is the other factor?
2x squared minus 2x minus 2.
2x squared minus 2x minus 2. Yes. So it takes a little bit of getting used to the synthetic division, but it's a lot faster when you can use it. Now, if x minus 3/2 is a factor, which it is, what does that mean about the number 3/2 itself? 3/2 is a
0.
It's a 0. What's another word we use for it?
Root.
A root. It's also an x-intercept. This graph would cross the x-axis at 1.5. Where else would it cross the x-axis? I don't know. I'd have to take that quadratic equation and solve it. So I know this one is 1.5 if I wanted to find the roots. This one I'd either have to try to factor it or use quadratic formula. And whatever I get for the answers here, that's the other two places where it crosses the x-axis, as long as they're not imaginary. If they were imaginary, that wouldn't count. Let's try another one. So it says use synthetic division to find the quotient and the remainder. Now, am I dividing by something that's in the right format? No. What's the format supposed to be?
X minus the number.
It's supposed to be x minus a number. And whatever number is in that box, that's what's supposed to go on the outside. How can we think of x plus 3?
Minus negative
Right. Think of it as minus 3. So what's going to go on the outside of my synthetic division?
Minus 3.
Minus 3. And what about the numbers on the inside?
3, 7, 1, and negative 11.
3, 7, 0, 1, negative 11.
So if you are missing a term, you need to fill in a 0 for the one you're missing. Okay. What's my first step? Bring down the 3. Now multiply. What's negative 3 times 3? Negative 9. And what do we do with the numbers in that column this time? Add them. What's 7 plus negative 9? Negative 2. Now multiply what times what?
Negative 3 times negative 2.
Negative 3 times negative 2, which is?
6.
And add them, we get
6.
6. What's negative 3 times 6?
Negative 18.
Add them.
Negative 17.
And negative 17 times negative 3, 51. And add them.
Negative 40.
Yeah.
Or 40.
40.
Also 40.
Okay, so let's write the quotient and the remainder. Well, let's start with the remainder. The remainder is 40. What is my quotient?
3x to the 4
So that's to the third column. Yep.
minus 2x
We already did the
to
cubed
the
column.
second
To the second.
plus 6x minus 17.
So that's your quotient and remainder. It's a lot faster of an algorithm than long division. Also takes up a lot less space. That's all the work right there. So what does that mean about x plus 3? It is not a factor. What does that mean about what does that mean about the negative 3? That's not a what?
Root.
That's not a root. So x plus 3 is not a factor. The negative 3 itself is not a root. It's not a 0. It's not an x-intercept. Okay. So this is always the number that if it did work, if the remainder had come out to be 0, then the number in this box would have been a root. But it did not come out remainder 0. Okay. Questions on it? Yes?
For the quotient, why would it be 3x cubed instead of 3x to the 4th?
Because if you did 3x to the 4th, you'd have to the 4th, to the 3rd, to the 2nd, to the 1st.
You just chop off.
Now you don't have your constant.
So, oh, okay.
You have to have everything from the
Yeah,
highest
I
exponent. You basically have to have everything down to 0.
Okay.
So 3, 2, 1, 0. And you have to have it before that line. This is a remainder, so it's separate. Yeah. Okay. I want to show that 3 is not a 0. So instead of doing that directly, I'm going to show that that is not something. What would the 3 have come from?
X minus 3.
It would have come from an x minus 3. So instead of showing that 3 is not a 0, I'm going to show that x minus 3 is not a factor, which means the same thing. To show that x minus 3 is not a factor, I'm going to do division, and I'm going to hope what happens if I do not want it to be a factor.
There's a
It does
remainder.
not.
There's a remainder. Okay, so let's do the division, but we'll do it the quick way. Take the root, put it on the outside. What would be my coefficients on the inside?
2, 5, -2, 3.
3. Bring down the 2. What's 3 times 2?
6.
5 and 6. 3 times 11.
33.
-2 plus 33.
31.
3 times 31.
93.
93. And what's -3 plus 93?
90.
90. What's my remainder there?
90.
90. So because when I tried to divide that by that, I got a remainder, that means x minus 3 is not a factor, which then means 3 is not a root. It's not a 0.
So that's all we have to do if it says, show it's not a 0.
Yes. And I'll just put the reason why here. That's a non-zero remainder. Had you gotten a 0 remainder, then that would have meant x minus 3 is a factor, which would have meant 3 is a root. Questions on that one? Okay. So now, we're going to finish up with a few problems where we find the zeros. And the strategies that we generally use to find the zeros of an equation is you start out by making a list of possible options with the rational root theorem. You narrow those options down by graphing it on the calculator. And then if you find one that works, you divide through using synthetic division. The reason we divide through by it is because look at what happened in this one. This one had a remainder of 0. I started with a cubic. When I did the division, the quotient ended up as a what? It wasn't a cubic anymore.
It was a square.
It was the square. It was a quadratic. That's always the goal. We can't work with a cubic. We don't have a formula that we've learned in here to do it. But we do know how to work with quadratics. Every time you use synthetic division, you're going to take the exponent that you started with, and the synthetic division is going to bring it down 1. But the trick is you have to find a number here that you can divide and get a remainder of 0. That's what the rational root theorem is going to help you find. Otherwise, if you didn't have that, I mean, what are you going to do? Just guess every number you can think of to try? That's going to take too long with synthetic division. We only want to do the synthetic division with a number we already know is going to work. We don't want to be guessing. It takes way too long. So let's start with the rational root theorem. What are all the factors of p? Well, let's just start at what is p in this problem? A 2. What are all the factors of 2?
2 and 1.
Not that many. Not as many as the first problem. What's q in this case? 1. It's all the factors of the leading coefficient. What are all the factors of 1?
1.
Just 1. And -1. So if I take all the different p's and put them over all the different q's, what numbers would be in my list? There's not as many as the first time.
Plus minus 1 and plus minus 2.
Right. Since q is a 1, dividing by q doesn't do anything in this problem. It's just plus or minus 1 over 1. plus or minus 2 over 1. So if this graph is going to cross the x-axis at a number that can be written as a fraction, it's either going to be 1, -1, 2, or -2. So I only have 4 choices. But I don't want to do synthetic division 4 times till I find the right one. I just want to graph it and see which one it is. But because I know it's between -2 and +2, I know where to look now. If I didn't have a list of rational roots, how would I know where to look? Maybe it would be at +10 or -20. I wouldn't know. Okay, but now I have a list. So let's type in x cubed minus 3x, x cubed minus 3x minus 2. Let's do zoom 6. Let's look if it's 1, -1, 2, -2. Could also be more than 1. Do any numbers in that list look reasonable?
-1, 2.
Yeah, -1 and +2. If you find 2 that work, it doesn't matter which one you use. Just start with either one. Let's check +2. So let's go to trace, press 2. Yes, 2 is a root. Okay, so 2 works. So let's start making a list of answers. Now, you might say, well, why don't you just do second calc 0 and get the other one? Yeah, I could in this problem. I could get the other one without doing any synthetic division. The problem is going to be, what if the other answer wasn't on the graph? What if it was something you couldn't see, like it was imaginary? The only way you're going to be able to find it if it's imaginary is with synthetic division and quadratic formula. So that's why we're going to do the synthetic division. So we know 2 is a root. Let's divide through by it synthetically. So put down your 2. 1, 0, -3, -2. Because it's a root, I already know my remainder. What's my remainder going to be? 0. I don't care about the remainder. I care about the quotient. I need something that I can solve and get the other answers. And I can't use a cubic. I need it to be a degree 2 or lower, and then I can use quadratic formula. So bring down the 1. What's 2 times 1? Add that up, we get 2. What's 2 times 2?
4.
Add that up, and we get
1,
1. 2 times 1,
2,
and then add that up.
0.
There's my remainder of 0, which I already knew that. But this is what I'm interested in. X squared plus 2x plus 1. So you already got your first root. Now set your quotient equal to 0 and solve that. Because it's a quadratic, you do not need rational root theorem again. You can just factor that and get your answers. How would that factor?
X plus, X plus. Oh,
Yep, an x plus and an x plus.
that would add up to 3.
A 1 and a 1. What number would you plug into the first factor to make it 0? And we're going to add that number to our list. -1. And what number would you plug into the second factor to make it 0? Well, it's the same number. So that's why this graph only crosses the x-axis at +2 and -1. You don't need to write -1 twice, even though it does occur twice. That's called a repeated root. Okay. So that's the general process. Rational root theorem, synthetic division, factor, or quadratic formula if you can't factor. Okay, let me just see, I had a bunch. They're all kind of the same thing. We'll try this one. If we have time, we can try that one. Okay, find all rational zeros. Okay, I don't even know where to start. So what's my first step to get a list of possible numbers to work with? Find the factors, do the P's and Q's. Okay, P in this case is what number? Okay, -1. What are all the factors of negative 1? 1 and negative 1. Okay. What's Q in this case?
6.
6. I think we've done that one before. What are all my factors of 6?
1, 2, 3,
6. And now my possible rational roots. Those are the P over Q's. So 1 over 1, 1 over 2, 1 over 3, and 1 over 6. So if this is going to cross the x-axis at a nice number, it's going to be between negative 1 and positive 1. That covers all my rational roots. Negative 1 to positive 1. So how am I going to narrow this list down? Because I have 8 numbers. And if I get really unlucky, I could just try 7 in a row and they don't work, and then I finally find one that does. It's going to take me like 20 minutes to do that. Yeah?
Graph to eliminate.
Yeah, we're going to graph. We're going to eliminate any ones that don't make sense. Okay, so we've got 6x cubed. We've got minus 5x squared plus 3x minus 1. And since I know all my roots are between negative 1 and 1, I'm going to zoom in a little bit between negative 2 and 2. If the graph goes off the screen, I don't care about that. All I care is, can I see where it crosses the x-axis? Can I see the roots? So let's hit graph. And out of those 8 numbers, which one looks reasonable? I would say it's probably the positive 1/2. So I can check it by pressing trace and see what the y value is. If it's 0, then that's the answer. That's the answer. So we know that 1/2 is a root. If that wasn't a root and none of these worked, then we'd be stuck. Because we'd have a cubic with no way to turn it into a quadratic. Okay? But we got a root. You always will. At least with the problems I give you. So one of the roots is 1/2. What are we going to use now to turn the cubic into a quadratic? Yep, use synthetic division. It's like we're going to take out the x minus 1/2 factor from this cubic, and we'll be left with a quadratic. So we got 6, negative 5, 3, negative 1. Okay, first step. 6, half of 6.
3.
3.
Add that up.
Negative 2.
Half of negative 2.
Negative 1.
Add that up.
2.
And then half of 2.
1.
And add that up.
0.
0. We already knew that. We already knew we were going to get a remainder of 0. What we're interested in is the quotient. What is that when you write it out?
6x squared minus 2x plus 2.
Plus 2. Set the quotient equal to 0 and solve it. But now we can definitely solve it because it's a quadratic. It's no longer a cubic. You could try factoring it. You could try 2x and 3x. And what would my signs have to be?
A plus and a minus.
Minus.
They have to both be minus, so we get a negative here and a positive here. What are 2 numbers that multiply to give me 2?
2 and 1.
So we could try like a 2 and a 1. Problem is that's going to give me negative 4x minus 3. Negative 4 minus 3 is negative 7. So that's not going to work. If you switch the numbers, well, that's still not going to work. Now that gives you negative 2x minus 6x. Wait, is that what I had before? That's negative 2x minus 6x. That's negative 7.
Yeah.
Is that the same thing I had before?
Yeah.
So if you switch them, that's negative 4x minus 3x. That's still negative. So that doesn't work either. So you could try a 6x and a 1x, but that's still not going to work. This is not factorable. So what do we have to do? We have to solve this equation, but we can't factor it.
Quadratic formula?
We have to use quadratic formula. Yep. What's the A in this case? 6. The B? -2. And the C? 2. Okay, so we got negative B plus or minus the square root of B squared minus 4 times A times C. Well, I can stop. I already see what's happening. Why can I stop now?
It's a negative.
I'm going to end up with a negative under the square root. B squared minus 4 times A times C. When you try to take the square root of a negative number, what kind of answer do you get?
Imaginary.
You get imaginary. We're not doing imaginary in this section. So tomorrow we would continue with it. Or if it didn't come out imaginary, we would continue with it. But it does, so we stop. So the only real root in this problem is 1/2. Okay? I think there will be one in the homework where this does not come out negative, and you need to keep going and finish it up. Okay, so it takes a little bit of practice, but once you get it, it's that rational root theorem, synthetic division, quadratic formula, or factor, every time. Okay. So we were going to do that one, but we're going to hold off on that. So that's homework for tonight. You will not need synthetic division on every problem. Okay? Like if they gave you one like this, well, that's the easy level problem they could give you because it's already factored. You just have to tell me the two numbers. So you might have some that are that level, but then you might have some like the last problem. You gotta do the synthetic division and all. Just a reminder, I'll be after school tomorrow for extra help in case anybody wants to come by. And we have our test on Thursday. Test on Thursday. But you will have time to finish the test on Friday.